Hi everyone. In this video we are going to discuss intermediate value theorem and its proof. So this is a statement of intermediate value theorem, but see in some books some author gives different statement of intermediate value theorem, but see both of them have the same meaning. Getting? Both statements are parallel. So the book which I am following, this statement of intermediate value theorem is given, so I have written the same and we are going to discuss its proof. Okay. So this statement is related with continuous function which is defined on this closed interval AB. If the function f has two different signs at the endpoints, just like f of a and f of b have opposite signs, f of a is negative then f of b is positive, or f of a is positive then f of b is negative, then this statement says the function f has value 0 at some point c which lies in this interval, open interval AB. Okay, so let us write the given information one by one. We have f is continuous on closed interval AB. So what will I do? I will draw the diagram simultaneously so you can easily understand the meaning. Okay, a very rough sketch I am drawing here. This is a x-axis, y-axis, AB is an interval and we have a continuous function defined on this closed interval AB. Second information is, and f of a is negative and f of b is positive. At a, function has negative value and b, function has positive value. Negative means below x-axis. Positive, that means above x-axis you will get some value. Okay, then we have to prove that, let me mention, to prove that there exists some point c in open interval AB such that f of c is equal to 0. This thing we have to prove. Okay, so actually it's very common sense, no? If one point we have below x-axis, second point we have above x-axis, and we are saying the function is continuous. That means we should draw a continuous curve which join these 2 points. Then definitely there will be some point between a and b where f of c is 0. That means that curve will cut x-axis. It's very obvious thing. You can draw any curve, continuous curve, okay, from f of a to f of b, then definitely it will cut x-axis at some point c. Okay, this thing we have to prove. So the proof is quite constructive. Okay, so let us start. What will I do? Whatever the interval we have, I am going to call it as z0. Okay, so it is closed interval AB. So this closed interval I am calling it as z0. Then I will take a midpoint. Okay, so let, and I am calling it as C1. C1 is equal to a plus b by 2. Okay, so let me draw another diagram to show all these things. Okay, this is y-axis, x-axis. We have interval AB here, okay, and we have a continuous function f from f of a to f of b. What I am doing, I am taking midpoint of AB, a plus b by 2, okay, a plus b by 2. So that is C1, that is C1. So by law of trichotomy, there will be 3 possibilities. Either f of C1 is 0, or it is positive, or it is negative. So let me mention here, I will mention, then f of C1 is equal to 0, or f of C1, let me write properly, f of C1 is positive or f of C1 is negative. Getting? So that means this curve passes to point C1. That means f of C1 is 0, or f of C1 is positive like this, or f of C1 will be negative. Okay. So if f of C1 is 0, if f of C1 is 0, okay, let me draw another diagram to show what I want to say. A, B function is like this. C1 is a midpoint of A and B. If this curve passes to point C1 exactly, getting exactly at point C1, then you will have f of c1 is equal to 0. And actually we are in a search of such point, no? So c1 is a required point in this case, okay? Then c1 is the required point. So we got our required point, and the proof will be over if this case will happen. Getting? So actually we should consider the remaining two cases also. Let us see what will happen if f of c1 is positive. F of c1 is positive, that means the situation will be like this. c1 is here, f of c1 will be here. It is positive, that means above the x-axis. Getting? In that case, what will I do? Let me write. If f of c1 is positive, then I am going to select j1 is equal to a comma c1. Okay, so what will I do? With the help of diagram, I will try to tell you. Okay, very small diagram I am drawing. A is here, B is here, C1 is here, which is a midpoint. Getting? So situation is like this. F of A is here, F of B is here. Okay, so C1 is positive, that means like this. So you can easily see at point A function has negative value, at point C1 the function has positive value. So my next interval is A comma C1. Since the condition is at the end points of interval the function should have opposite signs. In these intervals, at C1 function is positive, at B also function is positive. So we should not consider that interval. But if you consider this sub-interval, at point A the function is negative, and at point C1 the function is positive. That means at the endpoints of this sub-interval the function have opposite signs. Okay, the function have opposite signs. So that's why that will be my next interval J1. Okay. Let us consider the last case also. F of c1 is negative. If f of c1 is negative, then my j1 will be, okay, so can you guess what will be my j1? Let me draw a very small and rough sketch to show what is happening actually. So the graph will be like this. You know the c1 is a midpoint. Getting? But in this case f of a is negative. F of a is negative. F of c1 is also negative. F of c1 is also negative, and f of b is positive. That means at point c1 the function has negative value. At point b the function has positive value. That means if you consider this subinterval, at the end points the function is having opposite values. So that's why my j1 will be c1 comma b. That means it depends, okay, it depends on the value of f at c1, we decide what will be my next subinterval. You are getting what I am trying to do? This is the original set. I am dividing in two parts. So obviously we will get two subintervals, either this one or that one. So we select the next subinterval by observing the value of f at c1, okay. So j1 is my next subinterval, okay. Let me remove. But see, it is looking complicated, no? A comma c1, c1 comma b. So to make the symbol more simple, okay, what will I do? We will call j1 is equal to a1 comma b1. Okay, so that means if you get this subinterval, then this is my a1, this is b1, and if you get this subinterval, this is my a1, this is b1. To make the symbols more simple, okay, I have called that j1 as a1 comma b1. So let us go further. Just make a screenshot of it, then I will go further. Okay, so now what will I do? Okay, so j1 already we have a1 comma b1. Okay, so what we have done, we have divided this main interval j0 in two parts, and see, I am selecting one of this sub interval is my j1. Okay, so let us consider this is my j1. Okay, consider this is my j1. So this is my a1 now, and this is my b1, right? So again I will divide. Okay, let us take one midpoint. Let c2 is equal to a1 plus b1 by 2. c2 is a1 plus b1 by 2. That means it will be exactly at the middle. This is my c2. Agree? So now again there will be three cases by law of trichotomy. Then f of C2 is 0 or f of C2 is positive or f of C2 is negative. So if we are getting f of C2 is 0, if f of C2 is 0, it means f of B positive, f of A negative, f of C2 is 0, that means that curve is passing through point C2, getting? So that means C2 is a required point. Then C2 is the required point, getting? So we are in a search of C where the function value of function is 0. So it is a required point. So now we need to consider remaining two cases also. So if f of C2 is so if f of C2 is positive, then case will be like this, okay? It is positive like this. That means at A1 the function has negative value, but the C2 the function has positive value. So in that case we need to consider J2 is equal to A1 comma C2, getting? Since at this interval at the end points the function is having opposite signs, getting? At A1 the function has negative sign, at C2 function has positive sign, so that will be my second subinterval, okay? If, will you guess if f of C2 is negative, then can you guess J2 should be what? If the C2 and B1 the function has opposite signs, then my interval should be C2 comma B1, right? Okay. So in this way I got J2. But see, again these symbols are complicated, so to make them more simple, we will say my J2 is A2 comma B2. Okay, so I got my second subinterval. That means what we are doing, this is the interval we have. So we have divided in two parts. Again we got this subinterval, suppose. Again I am dividing in two parts. So after that I will again select a subinterval. Again I will divide it in two parts. So in this way we are going to repeat this procedure, okay? So let me write one more case and then we will conclude. Okay, so we will, I got J2. So will you guess? Then again I will select my C3, which will be A2 plus B2 by 2. So I am taking the midpoint of A2 and B2. So by law of trichotomy, f of C2 is 0 or f of C2 is positive or f of C2 is negative. Let me mention. Then f of C3, sorry, not C2, C3 is 0 or f of C3 is positive or f of C3 is negative, like this. Okay, I will repeat the same thing. If f of C3 is 0, then C3 is required point. C3 is required point. Okay, see, I am going fast since I am going to write the same statements again for that interval J2 and point C3. Okay, so that's why. If f of C3 is positive, if f of C3 is positive, then my J3 will be, will you guess my J3 will be what? My J3 will be A2 comma C3, getting? Just like this. If f of C3 is negative, then my J3 will be C3 comma B2. So the condition is the function should have opposite signs at the end points of interval. This is the only condition, so that's why we are selecting Jth in this way, right? And we will continue this process. Okay, we will continue this process. Okay, so just make a screenshot of it, then we will go further. So see what we are doing. We are dividing the intervals, okay, in subintervals. Dividing the interval in subintervals, okay, and each time we are expecting at the middle point we are getting the required point C where the function has value 0. So we are expecting that after finite number of steps we will get some point C where the function has value 0. Let me mention. Then after finite number of steps, we will get some Cn such that f of Cn is equal to 0. So this is our required value of C where the function has value 0, right? But see, there is no guarantee, no. So maybe if we repeat this process for infinite number of times, then also we will never get such point C where the function has value 0. So we need to consider that second case also, okay? Otherwise, I should mention, otherwise we will get a sequence of sets Zn such that, okay, such that. So see, that means if this process will never terminate, that means if the second case is if we will never get point C where the function has value 0, that means each time we are constructing a new set. Started with Z0, Z1, Z2, Z3, Z4, Z5, Z6, Z10, Z100, Z1000, Z and so on, Zn. Okay, it will never terminate. So in this case, we will get a sequence of sets Zn such that the first condition is Zn plus 1 is subset of Zn. Okay, so yeah, it's proper subset. Zn plus 1 is subset of Zn for all n belongs to set of natural number. Getting? Since we are dividing the interval, subinterval or interval in two parts and we are constructing a new interval. So obviously the next one is a subset of the previous one. Second is Zn is closed for all n belongs to set of natural number. Okay, we started with a closed interval a comma b, and each time we are constructing a new subinterval which is also closed interval. So obviously every closed interval is closed set with a usual matrix. So each Zn is closed. And let us talk about the length of Zn. So length of Zn, actually it is half of length of previous interval, that means length of Zn minus 1. Length of Zn minus 1 is half of length of Zn minus 2. So by 4 will be there, or you can say 2 square. In this way we can continue, and at the end we will get length of Z0, and you will get at the bottom 2 raised to n. Each time we are saying half of the previous one, half of the previous one, half of the previous one. So each time we are adding 2, okay? We are adding that means multiplying 2 to the denominator. So the, at the end denominator will be 2 raised to n. And length of Z0, what was my Z0? My Z0 was closed interval AB, so its length will be calculated as b minus a by 2. It's b minus a, and 2 raised to n is already there, right? So let us move further. Okay, see, as you can see, the numerator is fixed, and in denominator we have 2 raised to n. That means if n tends to infinity, denominator will go to infinity. It means the value goes to 0. Therefore length of Zn tends to 0 as n tends to infinity. I hope you understood. As n tends to infinity, this will be infinity, and 1 upon infinity is 0. That's why. So these three conditions we have. Actually these are conditions of nested interval theorem. That means our sequence of set Zn satisfies all conditions of nested interval theorem. So therefore by nested interval theorem, so that nested interval theorem says the intersection of Zn, n belongs to set of natural number, is non-empty. So intersection of all this Zn is non-empty. That means definitely we can find at least one point. So therefore we can find there exists some C belongs to intersection Zn, n belongs to set of natural number. It is in intersection, that means it is present in each and every set. So that means C belongs to Zn, and what is my Zn? This is n comma bn. It is true for all n belongs to set of natural number, right? So C belongs to this interval. That means an less than or equal to C less than bn for all n belongs to set of natural number. Okay, so just make a screenshot of it, then I will go further. So let us focus on the situation what we have. See, this is interval Jn we have, an and bn, and we have some point c between them. Then obviously, then mod c minus n, that means the distance between c and n is less than or equal to length of Jn. Agree? Less than or this is the Jn, no? This is interval Jn. So distance between these 2 points is obviously less than or equal to length of Jn, and which goes to 0 as n tends to infinity. And same thing we can write for mod bn minus c, that means distance between bn and c less than or equal to length of Jn, and it goes to 0 as n tends to infinity. So what I want to say, this distance goes to 0, that means n is approaching to c. Therefore, n goes to c. See, distance between these 2 points is reducing and it is going to 0. C is fixed, it cannot move, getting? But definitely n can vary, it depends on the n. So n moves to c, and similarly here we can say, and bn goes to c. But see what we have, the very important information, that function is continuous. See, let me mention, but f from close interval ab to r is continuous. Okay, so there is one result. Let me tell you that result, and then I will directly use, if xn converges to p and the function is continuous, then f of xn converges to f of p. This result I am going to use. Function is continuous and n converges to c, so therefore f of n converges to f of c. And what can I write for this one? And obviously f of bn converges to f of c. Okay, function is continuous again, bn converges to c, so f of bn converges to f of c. Okay, so just make a screenshot of it, then I will go further. See, but f of n is the, see, starting point of each subinterval. So therefore f of n less than 0. Okay, so I have already stated this thing. So this is n comma bn. So I have already told you at the endpoints of interval, the function should have opposite signs, get it? Just like this. So therefore f of n is negative and f of bn is positive. So see, f of n less than 0, but f of n converges to f of c, therefore f of c is also less than or equal to 0, let me call it as 1, and similarly f of b is f of bn, right? F of bn is greater than 0, it's positive, and f of bn converges to c, that means f of c is greater than or equal to 0. So we get this type of equality, so when we have a convergence. In statement 1 we are saying f of c less than or equal to 0, and in statement 2 we are saying f of c greater than or equal to 0. So if you use 1 and 2, you can easily say from 1 and 2 f of c is equal to 0. So we got finally the required point c where the function has value 0, right? So just make a screenshot of it, then we will stop. Thank you. See you in next video.